right, the notes you are getting ready to take and complete on your own are regarding something called compound inequalities. Just like in English, a compound sentence is combined by a conjunction like and, or, but, those sort of things. In algebra, inequalities are joined by only two conjunctions, and that's either the word and or the word or. Right? So the graphs for each one will look a little different, as well as the actual writing of the inequality. So for the first examples, I am going to do both of these with you so that you can see the difference between the two types. For number one, this is what is known as an and inequality. You will never see the word and in there, but you know it's that way when the x or the variable is sandwiched in between two numbers. So the way this works is on your number line, you're going to take and put the two numbers that are on the left and the right side of your inequality. So you'll start with 3 and then you'll end with 5, and then in our case 4 is smack dab in the middle. Okay, you still have to pay attention to your open and closed circles. Right? The 3 has a less than sign attached to it, so that's going to be an open circle on the 3. The 5 also has a sign on it without the equal sign, so that's also going to be an open circle. Remember, your circles are only closed when there's a piece of the equal bar underneath. Now, the way this is read, x is all the numbers between 3 and 5. So when you go to shade on your number line, you shade all of the numbers that are in between 3 and 5. Right? So that's the way that graph will look. When you go to number 2, you'll notice that it's two inequalities joined by the word or, right? And this is known as an or inequality, or compound inequality made of or, right? You're going to graph each one of them separately, but in the same number line, right? So the two numbers you need, and you always go from least to greatest, are going to be -4, and then the largest one you're going to need is -1. And then you can just pick a number that's either kind of halfway in between or close to one or the other. Just as long as you have 3 numbers in the number line, then we're good. Okay? And then you're going to use that to graph it. So for x is less than or equal to -4, I put a closed circle on -4, and I shade left for less than. For x is greater or equal to -1, same number line. On -1, I also put a closed circle, but because it's greater than or equal to, it goes to the right. You will notice the difference between these two graphs. The and inequalities, which is the one that does not have the word or, okay, is the graph in between 2 points. The or inequalities, right, which does have the word or, is the 2 points and then it's shaded outward. Right? So that is going to be a common thing that you're going to have to look for in determining which one is which. Okay, so for numbers 3 and 4, now you're going to have to practice writing them from words and numbers, and then from that turning around and graphing them. Sometimes this is one of the trickiest things to do for students. So pay attention carefully to your wording and make sure that you're doing them correctly. For number 3, it says all real numbers that are greater than or equal to -2 and less than 3. As soon as you see the phrase and right there, you know this is an and inequality. So the word or is not going to exist. And the way you want to handle these is you always want to put the smallest number on the left, so that would be my -2, and your largest number on the right, which would be my 3. And because I know it's an and problem, then that means my x, or variable, is sandwiched in the middle. Okay? The best way to deal with this is to deal with the part of your inequality that has the variable on the left and the number on the right. So I'm only going to pay attention to the x and the 3 right now. And in the phrase of my words, it said that my value has to be less than 3. So for x, I'm going to put x is less than 3. Now to get your other symbol, okay, it's kind of backwards, right? Because your symbols have to be facing in the same direction. I can't put a greater than or equal to sign in between the -2 and the x. It just doesn't work that way, right? So whichever way your left symbol will be facing is the same direction your right symbol was facing. So my right symbol is less than, it points to the left. My first symbol is also going to point to the left, right? But then it also needs the equal to piece, right? And if you take and flip around -2 less than or equal to x, it will say that x is greater than or equal to -2, right? So it is a little different, and it is going to take some thought process behind it. It's not just something that you're going to be able to pop out and do without thinking about it. Now the graph part is going to be easy. If you've actually written it correctly, the graphing is going to come out to be the best, right? -2 and +3, and then 0 somewhere in the middle, so that's what I'll pick as my third number. -2 has a symbol that has an equal sign attached to it, so I know that's going to be a closed circle. And then 3 has a symbol with no equal sign, so I know that one's going to be an open circle. Because the x is sandwiched in between the two numbers, I am going to shade in between my two circles. Okay, so the graphing is the easiest part. Writing it is a little harder. When you get to number 4, though, This one's going to be even easier to write. The or problems are easier to write than the and problems, right? And the reason behind that is because it's two separate inequalities, but it has the word or written in it, right? So you read it in two separate chunks. All real numbers that are less than or equal to -3. You write that as x is less than or equal to -3. That's that first piece. Then you physically have to write the word or. Without that word or, it is not a correct statement. And then the other part is all real numbers that are greater than 0. So that would be the same variable x is greater than 0. Okay, now in terms of my number line, I need -3 is my smallest number, 0 is my largest number. I'll put -2 in there somewhere, or you can use -1, it doesn't matter, as long as it's a number between 0 and -3. For -3, I see my symbol has an equal piece behind it, so that means I need to shade my dot in. X is less than or equal to -3 would be shaded to the left. Okay, for 0, it's an open circle because it does not have a piece of the equal sign. X is greater than 0 would be all my numbers bigger than 0. Okay, so again, or problems shade outside, and problems shade inside. Right, so the next part we're going to deal with, and this is where you'll have to practice doing some on your own, is I will actually show you how to solve them and then turn around and graph them. Right, and the ones that I don't do with you are the ones that you have to complete for homework and come to class ready to discuss. Right, I'm going to do numbers 5 and 6 from this next section. Okay, but before we do that, realize that these are all related to the and inequalities, so there are no ors in this one. And compound inequalities have same direction symbols. In other words, they have to point in the same direction. If they don't, then it's not truly an and problem. And the graph is between two values, which is what you've already seen me demonstrate and go over above. Okay, so for number 5, when you go to solve these, you have to balance them a little different because there's a left side, a middle, and a right side. So what you do in the middle, you also have to do on the left and the right. It's like a threefold part, not just two. Okay, so we have -5 is less than or equal to 2x plus 3, which is less than 7. Okay, and the way you deal with this is exactly the same, but it's centered around the middle. You want to figure out what do you need to do and in what order to get that x by itself. So for 2x plus 3, the first thing I have to get rid of is the plus 3. I'm going to minus 3 in the middle, and what I do in the middle, I have to do on the left and on the right. Okay, and now simplify. -5 minus 3 is -8, less than or equal to 2x, which is less than 4. Okay, in order to get the 2 to go away from the x, I need to divide everybody by 2 on the middle, the left, and the right. And when I get done with this, I'm going to have my final answer. So I will have -4 is less than or equal to x, which is less than 2. And that'll tell me how to graph it. So I know I need -4 and +2, and I'll stick 0 in the middle because he goes there somewhere. For the -4, I need a closed circle. For the 2, I need an open circle. Because it's an and problem, we shade in between the two numbers. Okay, so that's what solving and then graphing looks like. So the solving kind of takes on a different approach because the inequalities look a little different. Okay, for number 6, right, same deal. You want to get the x by itself, so we were going to add 8 to the middle, the left, and the right. Okay, so now I've got 10 less than 3x, which is less than or equal to 18. I want to get x by itself. I want to divide everybody by 3, middle, left, and right. 3 does not go into 10, so remember that the rule is if it doesn't divide perfectly, you leave it a fraction. So this answer is going to be 10/3, which is less than x, and that is less than or equal to 6. Now when you go to graph this on a number line, you're going to have to estimate about where 10/3 is. If you turn 10/3 into a decimal, it's approximately 3.3. So you need to think about where you're going to put 3.3 on a number line. So I'm going to start with my number 3, and then I'm going to count 4, 5, and 6 so that I can find the proper placement for this. 3.3 is a little past the 3. And it's a less than sign, so I need an open circle about where it's going to be. It's not going to be perfect, but you got to get approximately the right area. And then 6 has a sign with the equal bar, so you're going to shade your circle in. It is still an and problem, so you shade in between the numbers. Okay, just make sure your open circle looks like it's open. Okay, so that's how you solve and inequalities. Your job is to do numbers 7 and 8 and come to class showing me that you understand a little bit about those. Okay. And the next section I want to go to is the back. Okay, and these are your OR inequalities. If it's not an AND one, it's an OR one. Those are your only two types of compound inequalities. Okay, I'm going to do number 9 with you, and then you're going to do 10, 11, and 12 before you come to class. Okay, with OR inequalities, you're literally solving two separate inequalities, and then you're going to take and graph your results. Before we do that, though, I'm going to fill in the blanks. OR compound inequalities have, you don't need that word and, you can just write the word opposite symbols. In other words, the two symbols will be in the opposite direction. Okay, and the graph is outside the two values. Okay, and if you want to have an easy way to remember that, the word OR starts with an O. The word outside also starts with an O. So if you remember that, you'll remember which way you need to shade your graphs. All right, for number 9, again, we're going to take each one of these inequalities and do them separately, and then we're going to write our final one with the word OR between it, and then turn around and graph it. For 6x minus 5 less than 7, it's a two-step inequality, so you add 5 to both sides. Now I've got 6x is less than 12. I'm going to divide by 6, and x is less than 2. That's the first side. Okay, then I'm going to take the second piece, which is the 8x plus 1 is greater than 25 part. I'm going to subtract 1 from both sides. I have 8x is greater than 24. I'm going to divide by 8, and x is greater than 3. Now I'm going to merge these two inequalities with the word OR. So my final answer will say x is less than 2 or x is greater than 3. You have to have the word OR. All right, so now when you go to do your number line, right, remember you have to have at least 3 numbers on your number line. So because 2 and 3 are right next to each other, you can just do 1, 2, and 3. That'll work. For 2, it's going to be an open circle because there's no piece of the equal sign. X is less than 2 would go left. X is greater than 3, still open circle, it's going to go right. Okay, so number 9 is finished. So now take what I've shown you here and do numbers 10, 11, and 12, and we'll see how your results come out on that one. Okay, if you jump down to the next section, it's going to deal with when you have to switch signs and why you'll have to switch signs. Both of these are AND problems, but that's not neither here nor there. That doesn't really matter. What really matters is why the sign switching is necessary. So I'm going to take number 13, and we're only solving them. There is no graphing to this. And I'm going to show you what it looks like when signs have to switch and then what happens to them. Okay, if I'm solving this, the x is in the middle and it's got other stuff attached to it, so we need to get rid of the things in the middle so that it's just an x by itself. We're going to add 1 in the middle and then add 1 on the left, add 1 on the right. So now I've got negative 2 less than negative 2x less than 6. In order to get x by itself, I have to divide the middle by negative 2, the left by negative 2, and the right by negative 2. The rule of inequality says that anytime you multiply or divide by a negative number, you must flip the signs. So negative 2 divided by negative 2 is positive 1. I'm going to flip my sign to greater than. I've got x in the middle. I'm going to flip my other sign to greater than, and then I'm going to have negative 3. Okay, now what's different about this is the fact that the littlest number is not on the left like you're used to. So if it really bugs you that it's going from big to little, you can reverse it and put negative 3 on the left, put your x in the middle, and put your positive 1 on the right, but make sure the arrows point to the right number. You notice that this symbol right here is pointing to the negative 3. You want to still keep it pointing to the negative 3 or it loses its meaning. And then when that one points to the left, your other one has to point to the left. Both of these are the same answer. One of them's written from big to little, the other one's little to big. So it really depends on your preference. I will accept both of them. Okay, so your job is going to be to practice with number 14, and we'll see what issues and questions you might have from that one. Okay, and then the last one that we're going to do together through the video is number 15. The question that it's asking is it a solution? Which means it's giving you an inequality and you have to solve it and determine if the number that is after the semicolon, the 4 in this case, is that going to be a solution to our answer? All right, so here's the way I want you to approach this. If I take 5 minus 3x is greater or equal to negative 7, I'm going to solve it for x. So I'm going to subtract 5. And I get negative 3x is greater or equal to negative 12. I'm going to divide by negative 3. Okay, because I'm dividing by a negative, I have to flip my sign the other direction. So now it's x is less than or equal to positive 4. So now they're telling you or asking you, is the value of 4 for x going to be a possible solution? It'll either be true or false. So if you take where the x is in your answer and you turn that to a 4, is 4 less than or equal to 4 a true statement? Well, because of this little piece of the equal sign right here, it is a true statement. So this one you would say true, or you can say yes. It doesn't matter which one of those two words you use. But you have to solve it first, and then you have to use the number they give you and test it out to see if it works. All right, so you're going to complete number 16, and then you're going to come to class, and we're going to take these notes and do a little bit more with them. All right, once you understand what's going on and once you know the difference between and or inequalities.